Welcome to Digital Softics. In this session, we are going to discuss about the software design strategies. So let's move on and see today's agenda. So today's agenda is what is software design, different software design strategies, such as structure design, function-oriented design, object-oriented design, and we have two approaches: top-down approach and bottom-up approach. So let's start. So what is software design? Software design is the process by which an agent creates a specification of a software artifact intended to accomplish a goal using a set of primitive components and subject to constraint. Software design usually involves problem solving and planning a software solutions. Basically, software design is the art or the graphical representation of system, and it specifies how the system will work, what functionality the system will deliver, and how these functions are implemented. So software design is a very important factor of software engineering when we develop software. So software design tells us that how the functions are performed by the software, or what are the functionality uh, delivered by the product. So software design is the process by which an agent creates specification of software. Means the user requirements are graph and the user requirements are implemented in the system. And software design tells us how the software will work. So it is the basic meaning of software where the in software design the user requirements are mapped, and it tell us that how the functionality provided by the system. So these are the things related to software design. So how to design software? So design strategies we have, different design strategies are as follows. Number one is structure design, function oriented design, object oriented design, and design process. So these are five are the major design strategies in which we design softwares. And we have the software design approaches, which A is top down design approach and bottom up design process. So we will study in the last module these two: top down design and bottom up design process. So number one is structure design. Structure design is based on divide and conquer strategy, where problem is divided into several subproblems. Each subproblem is individually solved until the whole problem is solved. The small pieces of problem are solved into solution module. In structure-oriented design, we divide the system into small components. That is why the complexity of the system is divided. So it is really very easy for us to design a sub problem rather than a big problem. So when the problem is divided, it is really very easy to design it, because we design small sub problem and we combine them to make a major software design. So each sub problem is individually solved until the whole problem is solved. So the small piece of problem are solved into solution modules. So structure design emphasizes that these modules will be organized in order to achieve a precise solution. So when these small problems or sub-modules will be organized in order to achieve the solution. These modules are arranged in hierarchy. They communicate with each other. A good structure design always follows some rules for communication among multiple modules. So there are various components in the system, and we divide the system, and there's a very proper communication. For example, if you want to design uh, the system of university, so we divide the university, one module administration, the next module is the different kinds of department. We have computer science department, biology department, and we divide the university into departments, and we design for software for that specific department. So when these sub problems or sub modules combine together, they make a system for university. So that is why structured design tell us that divide the problem into sub problem. So it is really very easy for us to design these kinds of problems with the help of structured design strategies. So structured design strategy tell us to divide and conquer strategy, where problem is divided into several sub problems. So we have the second word, function oriented design. In function oriented design, the system is comprised of many smaller subsystems as known as functions. These functions are capable of performing significant tasks in the system. The system is considered as top view of all functions. This design mechanism divides the whole system into smaller functions where provide means of abstraction by cancelling abstraction by the information or by the communication among these functions. These function modules can share information among themselves by means of information passing and using information available globally. So in structure design, we divide the system into sub modules, while in function oriented design, we divide the system based on the functionality. And we also design the system with the help of functionality, how many functions can perform by the system. So if the system can delivers us 10 functions, so we divide the system into 5 or 6 modules. So it is really very easy for us to design these kinds of system which have similar functionality and which is divided based on the functionality. So there is a proper communication and the proper way of exchange among the functions, because one function can call another function. For example, if you want to design a system for a calculator or a software for a calculator, so there's a GUI, graphic user interface for calculator, and there is a functions of addition where can they add numbers, multiply numbers, and divide numbers. So we specify a simple module for addition, a module for multiplication, and a module for division. So dividing the system based on the functionality. So when we divide something, they call this uh, a division module or division function. They divide the numbers. When we want to add numbers, so it called the addition module. So that is why the system is divided based on the functionality. So another characteristic of function is that when program calls a function, the function change the state of program, which sometimes is not acceptable by other module. Function-oriented design works well where the system state does not matter and programmer function work on input rather than on a state. So for example, a system have a lot of state. So a system have a specific state. For example, if I want to input numbers in the calculator, so they have a specific input state. So function oriented design tell us to design the system based on the functionalities. We divide the system based on the functionality, which is rather complex. That is why the function oriented design will also matter where the system does not change their state. When the system change their state, when program or function calling one another, so it is not a good idea to design the function oriented design for this kind of system where the state is changed. So this is function oriented design. So function oriented design process. Design process, the function where the whole system is seen as how data flow in the system by means of a data flow diagram. A DFD depicts how function change data and state of entire system. The entire system is logically broken down into smaller units as known as functions. On the basis of their operation in the system, as we discuss about, the system is divided based on the functionality. Each function is then described at large. So this is the process how to design the system with the help of function oriented design. So these are the steps in which we identify the how the data is change or exchange among the function, how the logically the system is divided into smaller functions, and how the function is described at large. So these are the process of uh, the function oriented design. Is the object oriented design. So object oriented design works around the entities and their characteristics instead of functions involved in the software system. So in function oriented design, we divide the system based on the functionality, while object oriented design be around the entities and their characteristics instead of functions. So these design strategies focus on entities and their characteristics. The whole concept of software solution revolves around the engaged entities. So let's see the important concepts of object-oriented design. So in object-oriented design, we design classes, we design objects. For example, if I want to design system for employees, so I will create employee class, and that have employee data functions, data members and function, and that class have specific data related to the employee. And now with the help of object I can access them. So let's see what are objects, what are classes. So objects, all entities involved in the solution design is known as object. For example, person, banks, company and customer are treated as object. Every entity has some attribute associated it, and it has some method to perform on the attribute. So functions object is um, a thing which is array, a thing that is to be person, banks, company and customers, so they are treated as objects. For example, for if I want to deliver a system and create a system for bank management system, so I create bank as a class, and with the help of bank, I can create employ a customer as a object. So with the help of object I can access the class. So object oriented programming and object oriented is a very important concept used in different languages rather than C doesn't support object oriented programming. So in object oriented programming we design classes, objects. So if you want to familiar with this object oriented design strategy, you must know about little bit about the object oriented programming. So these are very important. So don't worry, we have discussed these things related to the object oriented programming. So objects are entities involved in the solution design as our objects. So we have a class. As a class is generalized description of object. An object is an instance of a class. Class defines all the attributes which an object can have, and methods, which defines the functionality of object. In solution design, attributes or storage variables and function are defined by the means of methods of procedure. So in class we have the data members such as integer, float, char, string, and we have member functions. So it is void, input is a function, display is a function. So in class we have these two things, and with the help of object we can access the class data which is present and which have some gives us some kind of functionality. So we have object oriented design continue. So object oriented design have a very important concepts such as in encapsulations. In OAD, the attributes, data members, and methods of operation on data are bundled together is called encapsulation. So I discussed earlier that in class we have data members, they and member functions. Data members are integer, float, and all the variable and data types, and member functions are the functions which are included in the class. So these when these are combined together, they form encapsulation. Encapsulation not only bundles important information and object together, but also restrict access of a data and methods from the outside world. This is called information hiding. Encapsulation, we hide information with the help of access specified private. So when we declare the data members and member function as a private, so we encapsulating them, and we can hiding them from outside the world and no one can access them. That is why when we declare something as a private, so they are related to us. They are private. They are not be public. They are not be accessed by other without our permission. So encapsulation not only bundles the important information. So encapsulations is encapsulated just like in capsules, which combine the member functions and the data members of a class and hide them from outside the world. Encapsulation is a very important concept of object-oriented programming. So we have inheritance. OOAD allows similar classes to stack up in hierarchy manner where the lower class, subclass, and import, implement, and reuse allow variables and methods from their immediate superclass. So in inheritance, we inherit classes from one. Like for example, if I have the class parent, so I can inherit another class that is child or son or daughter, whatever it is. So the second class is called the child class or the subclass, and the parent class, the father or the mother class, is called the super the super class. They have a lot of names. So this property object is known as inheritance. This make it easy to define specific class and create generalized classes from specific ones. So we derive classes from one another, say we expanding our system. So this is called inheritance. So if you are mm, not familiar with these concepts, so don't worry, we design another tutorial series for object oriented programming. So after that you will be able to design the system with the help of these concepts, and these are the design principles, main principles. So they are very necessary. So we have polymorphism. Object-oriented design language provide a mechanism where methods performing similar tasks but variant arguments can be assigned same name. This is called poly mean many, morphism mean forms, which allows a single interface performing tasks by different types depending upon the function invoked. Respective portion of code get executed. So polymorphism is a process. For example, if I have the area class, the area function I have. So in area function, I have passing two parameters, the radius and the other one, such as the radius. If I want to calculate the area of some kind of important shape in mathematics, such as length and breadth, like rectangle. So if I have another uh, shape which is square, so finding the square's area, I have passing and use the current area function that calculate the area of rectangle. So I can change the parameters, and with the help of them I can reuse the entire functions. So that is why it's called polymean many morphism mean forms. Design process. So software design process can be precise in series of well-defined steps, though it varies according to design approaches. Function-oriented design or object-oriented design yet have the following steps. A solution design is created from requirements of previous use system or sequence diagram. Objects are identified and grouped into a class on behalf of similarity attribute and characteristics. Class hierarchy relations among them and application framework design. So object-oriented design is very important, and this design process contain solution design created from requirements. Based on the requirements or previous system is used, object are identified and grouped into a class, and functionally are divided among these classes. Now we have software design approaches. Here are the two generic approaches for software designing. We top down design. Top down means coming from the top towards the down. We know the system is composed of more than one subsystem, and it contains a number of components. Further, these subsystems and components may have their own set of subsystems and components and create hierarchy structure in the system. Top-down design takes the whole software system as one entity and then decomposes it to achieve more than one subsystem or component based on some characteristics. For example, if I want to develop a system or develop or create a design for university, so my first module will be design, and my the second module will be the departments, and that department contain a lot of sub departments, such as the the computer science department. So in computer science department we have programs such as bachelor's, MS, PhDs. So the system is divided. We are coming from top towards the down, and we divide the system into component. So this is called top down design. We are coming from the top towards the down, and we divide the system into hierarchical form. We have the second one, which is the bottom up design. So the bottom up design model start with the most specific and basic component. It proceed with composing high level of component by using basic or lower level component. It keep creating high level component until the desired system into is not evolved as a single component. So it process or it proceed with the composing high level component by using basic or lower level components. So in bottom up design we going from bottom to up. So in bottom up design we specify this is, for example, if we consider the university. So if I want to design system for the whole university, and I was coming towards the department, and the department have a lot of activities. They have employees, and they have the classes schedule, they have the account sections. So if I specify these things for a department, so I am moving towards another department, and design these things with the department. So if I going towards the dean of the numerical science, dean of the physical science, everything. So I'm going towards the dean module. So after the dean, I'm going towards the administration module. So I'm going from bottom to up. I design the basic component of a system, and I move towards the higher components, and then I reach toward the university management system. So that is why I design the system from the lower level, from the department level, and I specify what the department contain, and I'm moving towards the dean and the administration and the upper top management of the university. So that is why it called the bottom up design. While in top-down design, I consider the big entities such as the university management system, and moving toward the administration, the dean, departments, and they have designed the system from the top towards the down. While in bottom-up design, I design the system from a basic component moving towards the higher component. So this is the bottom-up design approaches. So it's all about the software design strategies. If you have any kind of question related to this tutorial, so write your query or question in the comment section. We will try to give you a best solution of your queries, and we are also available for you uh, on the website, which is digitalsoftlix.com. You can visit for tutorials and for articles. Thanks for watching.